This is 6.5, the law of sines. The law of sines in trigonometry comes from recognizing that within a triangle, the sides are proportional to the sides of the corresponding angles. So notice what we have set up here. And you should recognize this from previous courses, but you have sine of A. So here we have, and really when you set this up, this is like it looks like three proportions, but really, and I'm just using this as an illustration, but you have, let's just look at this. So sine of A, so again, capital A means angle A. So sine of A over side A is proportional, or it equals the sine of B over B. So if you look at just that proportion, then you can set it up and solve the equation. Or again, you could look at sine of A over A equals sine of C over C, or sine of B over B equals sine of C over C. So any proportion of the angle, the sine of an angle over its side is equal to another sine of the angle over its side. So we're going to use that proportion, the law of sines, to help us solve a triangle. So let's look at our first example. So here we have a triangle with the certain measurements and a side, and we want to try to find side B. Now, two things. One, when I draw an angle up here or something like that, it may not be drawn to scale. So keep that in mind. I may draw a triangle and it may look like that angle's bigger than that angle. Just keep in mind that I'm just drawing a general triangle and the measurements are there, and they're trying to, I did try to draw them to scale, but again, they may not be drawn perfectly to scale. All right, so to solve this first one, all right, so on this problem, you're trying to find side B. So we're trying to find this. Whenever you use the law of sines, you want to set up or at least notice something that you do know. So I do know that angle B, and I know I'm trying to find side B. Okay, so keep that in mind, what you're trying to do. But I could find angle C. And so, because you remember a triangle adds up to be 180 degrees. So if I literally, and I know angle A and I know angle B, so I just have to take 180 minus 75 minus the 60, and I'm going to end up getting 45 degrees. So this letter C is 45 degrees. And notice I know this proportion. That's what you're always looking for. That's not a proportion, but the angle C and then angle or side C is what you want to use here. So I'm going to literally do sine of C over side C, because that I know, and I'm trying to find the B. So I'm going to use literally sine of B over side B. So that's the proportion I'm going to set up. Now, by the way, just as a side comment, back to the other page here. So when you set this proportion up, you don't have to have the sine of A up top. You could literally do A over sine of A equals B over sine of B equals C over sine of C. So it's the same proportion as what you're doing, depending on how you want to set this up. So I'm going to literally rewrite this just to make it a little bit easier. But by the way, sine of B is 60 degrees. I should have put that in there. Okay, so to actually solve this, all I'm going to do is I'm going to just multiply by, in algebra, you multiply by what you do on one side, you do the other. So I'm going to multiply by sine of 60, and that's going to cross it out. And that way I just have to do this calculation here. So basically 340 times sine of 60, and then divide that by sine of 40, and you're going to get approximately 416. So if we round to the nearest whole number. So side B is 416, and that's all the problem asks us to do, is solve for side B. So let's look at another problem. All right, now this problem says to solve the triangle. Anytime it says solve the triangle, that means I want all angles and I want all sides. So let's first do the easy one, angle B, because I know angle A and I know angle C. So, and then I know a triangle adds up to be 180 degrees. So all I have to do is take 180 minus 20 degrees minus 25 degrees to be able to get to angle B. So this is going to give me angle B. To be able to do that, which is 135 degrees. All right. So, and again, if I draw it to scale, even if I don't draw it to scale, but keep in mind 135 degrees, opposite of that, that's the biggest angle, 135 degrees, that should be the biggest side. And then opposite 25 degrees, angle C should be 80.4, and then opposite angle A, 20 degrees. So side A should be the smallest side, okay, because it's the smallest angle. So, all right, so with that in mind, now, how do I use the law of sines? Well, notice I do know angle C and I know side C. So I'm going to use that relationship. So I'm going to do sine of 25 degrees over 80.4. And then let's find, it doesn't make a difference. Let's do side A. So this would be sine of A, 20 degrees, and over side A. And you could have done B over, sine of B over B, either way. We're just gonna, let me go ahead and set up the other relationship. So even if you did the same thing, sine of 25 degrees over 80.4, and you could have done sine of 135 over side B. Okay, so if you're trying to find side A or side B, depending on which relationship you want to do. So that would give us, once we solve these, then that would give us the sides. So again, different ways to solve this. You can rewrite the proportion if you want, or just simply cross multiply. So if you cross multiply, you're going to get A sine of 25 equals 80.4 times sine of 20. Which means side A is 80.4 times sine of 20 divided by sine of 25. And that's going to give us that calculation, which gives us about 65.1. And then do the same thing with side B, and that's going to give us 134.5. So again, if I labeled everything, this is 134.5. Again, the biggest angle goes to the biggest side. Side A is 65.1. Again, the smallest angle goes with the smallest side. So I found all angles and I found all sides. So I solved the triangle. So let's look at, when you start looking at using the law of sines, it's possible that certain cases happen. So you might want to pause this in sometime in it and just make sure you understand. You might want to pause it and understand what I'm trying to say and understand the relationship of what I'm doing. So there's several possible scenarios when you're doing the law of sines. Now, the two examples I've done so far, we use the law of sines, you came up with an answer, okay? So here, the same exact thing. So here I have an angle, I have two sides, you can set up the proportion just like this, and it's solved for it, and you get a certain answer. Now, I do want to emphasize this. When you get down to this step, and you're trying to find the angle, now this is the first time we have an angle we're trying to find. The other ones we're trying to find a side. Here, trying to find an angle, when you get down to here, you have to ask yourself, sine of B equals 1/2. Now, where does sine of B, where does sine give you 1/2? So if you look at the unit circle, and remember it's cosine sine, so where does sine give you 1/2? Well, it could be here in the second quadrant, it could be here in the first quadrant, because both of those give you sine of 1/2, but which is basically at 30 degrees and 150 degrees. So which answer is it? Okay, so which answer is it? Well, it can't be 150. And you're like, well, why can't it be? Well, if I said angle B is 150 degrees, if I said that, that means angle A and angle B add up to be more than 180 degrees, which can't happen, okay? Remember, all three angles of a triangle have to add up to be 180 degrees. So just that fact alone, it cannot be 150. So it has to be 30 degrees. And then after that, you could solve the rest of the triangle just like we did in the prior problem. So once we find angle B, then we can find angle C, and then we can find the other side C, if we wanted to, doing that. So again, when you're trying to find an angle, you have to be very careful of where does it equal, in this case, positive 1/2. All right, so let's look at another possible scenario. So here's another example. Angle A is 43.1 degrees, and side A is 186, and side B is 248.6. Now, when you start to setting up a proportion, so again, I'm setting up a proportion, so look at the proportion that I set up. I know angle A, I know side A, so I'm going to use that. And I know side B, so that means I want to find angle B. So again, when you're trying to find an angle, you got to be careful. So the question says, where is sine of B? So once you set this up and solve it, and you get down to this step, where does sine of B give you 0.9125? So in other words, it's positive. Where is sine positive? Well, again, if you look at where is sine positive, we're talking about the first and the second quadrants. So we have two different scenarios. So I know it happens in the first and second quadrants. So let's tackle the possible scenario of the first quadrant. So to solve this right here, to actually solve this, so sine of B equals 0.91225, and then I'm just going to take the inverse sine of both sides. So when I do that, I get B is approximately, and that's how come I got that right there, is 65.8 degrees. So if angle B is, or if this triangle is in the first quadrant, then angle B is 65.8 degrees, so the triangle would look like that. So again, you might want to pause it and notice angle A is 43.1 degrees, side A is 186.2, and side B is 248.6. And so it could, and then I found angle B, which is 65.8. So the triangle could be that. But what if angle B, because again, this could be positive, it could be positive in the second quadrant. So all I did was, since I got this as 65.8, I took 180 degrees minus 65.8, and that's going to give me the 114.2. So angle B actually could be, because remember, you're always dealing with the reference angle, so angle B could be 114 degrees. So imagine 114.2 degrees. So imagine that. See, that's what the degree is, and that's where the triangle comes from. So angle B could be 114.2 degrees, which again, if you look at this triangle, I'm drawing angle B as 114.2, side A is still 186.2, angle A is 43.1, and so you can literally do this whole same scenario. It could be triangle 1, it could be triangle 2, and you have to consider both case scenarios to be able to do this. Okay, so we went over one type of problem where you actually get an answer. In this case, you actually get two possible scenarios. And then the third scenario, again, I'm just going to leave it to you, but it's possible when I give you a scenario like this, that there is no triangle that exists that actually fits those measurements. Because it literally won't, when you draw it out, the side just won't meet up with that angle. It just doesn't match. So that's another case scenario that you might want to consider when using the law of sines.